To do a one-way simple ANOVA, we're going to go and look at some data on clergy vocational satisfaction in different groups of those clergy by their position. So I've called up the data file here, and I'm going to show you how to use ANOVA to analyze that. ANOVA is under the Analyze menu, and then you go to General Linear Model and GLM Univariate, where you're just looking at one dependent variable. And so up here is the dependent variable slot. I'm going to go down to the variable I want to look at, which is career vocational satisfaction. Then there are two kinds of factors that could divide between the participants in a study. There are fixed factors and random factors. Fixed factors are factors where you have all of the possibilities represented in there, and so you've basically sampled every value of that factor. Random, you just have a random subset of the potential values of that factor. And then there are covariates, which are controls. We won't cover that in this class, but that goes with ANOVA, analysis of covariates. And covariates allowed you to put things at the same starting point and to basically control for certain background variables. You can also weight things differently. So down here, we want to look at the career and vocational satisfaction and look at that between different clerical positions. So that will be our fixed factor. Again, you always want to look at what your options are. Let me show you what those are here. Under Model, you can have it only include certain effects in the model, but we're going to keep it as full factorial. Contrasts, we'll talk about these in class. There are ways to do different kinds of contrasts, and if you want to look at those, all the standard ones are here. Deviation, simple, difference, Helmert, repeated, or polynomial contrasts. And if you want to use those contrasts, you just use it right here. We're not going to use any contrast here. Plots. This allows you to have profile plots of the marginal scores of different groups. And so we can put that here with clerical position on the horizontal axis and add it as a plot. Post hoc. Once you know that there's a difference, you want to know what that difference is. And it depends on whether or not you're assuming equal variance. But if you're assuming equal variance, then you can use the Tukey. We'll also bring up the Bonferroni just to show you the most conservative test. And we also will talk about Games-Howell when you can't assume equal variance of the different groups on the dependent variable, then you might want to use a correction such as the Games-Howell. Save allows you to save the models. This is basically a multiple regression with the independent variable values made into dummy variables, and so you can look at the regression and do diagnostics on it, but we won't do that here. And then finally, under options, you might want to find some of the means, for instance. And you'll want things like descriptive statistics right there, estimates of effect size, observed power, and the homogeneity tests. And there are all sorts of other things you can get in there if you like, if you want to look especially at the goodness of fit of your model. You can also get confidence intervals, and here, well, let's leave them at the 0.05 level. Hit OK, and here it comes. I'm going to maximize it so we can look. This is just translating what I did into the programming language of SPSS. And here we go. Here's the results. Here are the different values of the between subjects factors. Senior rector, curate, assistant, or associate, or non-parochial. These are the numbers of people in each group. Here are the mean value of career vocational satisfaction for each group and the standard deviation. Here is Levine's test for equality of error variances. Remember, the null hypothesis of this test, which it tells you right here, is that the error variance of the dependent variables is equal across groups. Here, that is not violated at the 0.05 level, and so we can assume that there is equal variance. Right here is our ANOVA table. Here are the sum of squares, degrees of freedom, mean square, the f of that, the significance, the effect size, the non-centralization parameter, and the observed power. The corrected model includes everything in it, and then here we have the intercept and the factor we're looking at, and the error variance, and this is the total variance and the corrected total variance. In a old-fashioned ANOVA table, you would have these three. And so you take sum of squares, divide by degrees of freedom to get mean square, and you look up the ratio of the mean squares to get f. This tells you the significance of that particular factor. So here, clerical position is significant at the 0.05 level, and this is the effect size, partial eta squared. Remember that we also like omega squared as perhaps a better estimate, and so to get there you'll have to do a little bit of calculation. But this kind of uncorrected partial eta squared shows us that 3% of the variance can be attributed to this factor. And the observed power would be 0.875, assuming that we were looking for an effect at the 0.05 level. Here are the estimated marginal means. This gives us a confidence interval for estimating what the means are associated with these different values based on the model we calculated. And then here are the post hoc tests. So you found that there's a difference between the groups, and you want to find which groups are different. So here, this is the Tukey, and that's the one we're going to use because, again, we went up and Levine's test showed that we could assume that there were equal variances amongst the different groups. This tests this category, this column, versus each one of the others. It finds the mean difference, the standard error associated with that difference, and then the significance. And so you can find, for instance, that senior rectors are significantly more satisfied, see, I minus J, senior rector minus the curate, than curate's assistants or associates. And that's significant at 0.03. This gives you a confidence interval for the difference between the two. There's no difference between senior rectors and regular rectors, and there's no difference at the 0.05 level between extraparochial. Again, we look through these different things, and we find that the only difference, as we scan down here, is between senior rectors and curates. And you can look at the Bonferroni, and if we needed it, the Games Howell would be there as well. This also shows you that the homogeneous subsets, these are things that are not significantly different, and it shows you that rector, non-parochial, and senior rector are all together, and rector and curate are together as well. And then this gives us a plot of it. The senior rector, curate, assistant, or associate, and non-parochial all plotted on the estimated mean value of career vocational satisfaction.